Hello! In this video, we use implicit differentiation to find an equation of the tangent line to the curve at the given point. So our first step is, when finding the tangent line here, my first step that I'm going to do is I'm going to find the slope. Now the slope I'll denote as m, and that's equal to dy dx evaluated at the point 2, 1. To find dy dx, I apply the derivative to both sides of this equation. So we're using implicit differentiation. Now, one of the properties of derivative is that I can, in a sense, distribute that over each of those. It's really actually called linearity. So I will take the derivative of each of those terms on the left-hand side. On the right-hand side, the derivative of 1 is 0. Now I'm taking the derivative with respect to x, so ddx of x squared is simply 2x. Now as I move forward, I have x times y, and I need to use the product rule. So the product rule says, well, I take the derivative first, and that gives x prime, multiply by the second, plus, leave the first alone, and the derivative of the second term, second factor. Now I come to y squared, and I'll finish that on the next step. The derivative of y squared is what? Well, that's 2y when I differentiate with respect to y, but I differentiate with respect to x, so I have to follow up with y prime, which is dy dx. So this guy right here is in fact y is a function of x squared. So first I take the derivative of that something squared and I write 2y. But then I follow up by the derivative of the inside, and the inside is y of x, so that derivative is y prime. And what we do each time is once you come to y squared or any function of y, you take the derivative 2y, and that's with respect to y, then you follow with y prime when you use implicit differentiation. Let's continue along here. I copy down 2x, come to x prime, that's 1 times y, and then I add x. The derivative of y is 1, but we multiply by y prime. Or you can just say we took away the parentheses there. Now, let's see if I can just distribute the negative here. It's all these little pieces that are important, otherwise the whole thing could be wrong. I am now going to put in x equals 2, y equals 1. I don't really need a formula for y prime, so I'm just going to put in x equals 2, y equals 1, and find y prime evaluated at 2, 1. I'll even call m, the slope, equals y prime now. So I'll get 2 times 2 minus 1 minus 2 times m minus 2 times 1m equals 0. Well, let's see, this is going to give 4 minus 1 minus 4m equals 0. 3 minus 4m equals 0. 3 equals 4m. And we're getting somewhere. M is equal to 3/4. Okay, that's the slope of the tangent line. It's the derivative dy dx evaluated at x equals 2, y equals 1. And now we're going to work on the tangent line. And I'll use the point slope form of a line. And I'm going to just plug in again x equals 2 and y equals 1. And m equals 3/4. I wrote the answer down there just to double check that I get this right. So y minus 1 equals 3/4 x. Three-fourths times negative 2 is negative 3/2. So y equals 3/4 x minus 3/2 plus 1. Finally, the answer's right over here that I worked out before. Y equals 3/4 x minus a half. It's amazing, really. Go through all that work and actually get the right answer. It surprises me. Okay, so let's zoom out a little. Actually, I'd have to say my final answer wasn't written in the most neat handwriting through all that. All right, that looks just fine. Okay, so that's finishes the problem. That problem is where we find the equation of the tangent line to the curve at the given point by using implicit differentiation.